Hey there, amazing viewers. Welcome back to AI for Beginners, step-by-step journey from novice to pro. If you haven't already, please hit that subscribe button to embark on this enlightening journey with us. Before we unravel today's insights, let's quickly recap our journey. We started off by peeling back the layers of the fascinating world of AI, tracing its riveting history. We then dove into the depths of algorithms, understanding their pivotal role in AI. Data, the lifeblood of AI, was our next stop, as we explored its significance and the importance of quality and quantity. We then acquainted ourselves with the leading platforms in the AI world, understanding their unique strengths and how they contribute to the AI ecosystem. Our journey then took us into the realm of classifiers, those powerful tools that help us make sense of complex data. But remember, creating a model is just the beginning. The real magic lies in refining it. Today, we're diving deep into the nuances of training and validating models. Let's dive right in. Picture teaching a young child to identify animals. You begin by showing them a fluffy, whiskered creature with a melodious purr, and you say, "This is a cat." Then, you introduce a playful, wagging tail creature with a bark, and you say, "That's a dog." You repeat this process with different animals. Over time, the child starts to distinguish between these animals and can name them independently. Now let's translate this process into the world of artificial intelligence. The act of showing the child different animals and their names is akin to feeding our AI model with training data. We're essentially teaching the model to discern patterns and make predictions. Just like the child who learns to distinguish a cat from a dog, our model learns to distinguish patterns within the data we provide. It could be anything from identifying spam emails to predicting stock market trends. The more varied and comprehensive our training data, the better our model learns. But remember, the learning process isn't simply about input and output. It's a dynamic, iterative process. Much like how a child learns through repetition and correction, our AI model learns through repeated exposure to data and tweaks in its algorithms. And just as we don't stop teaching a child after they've learned a few animals, we don't stop refining our AI model after its initial training. We continue to feed it new data, allowing it to learn, grow, and adapt. So what's the takeaway from this analogy? Training an AI model isn't a static one-and-done task. It's a dynamic process that involves feeding the model with data, allowing it to learn and make predictions, and then refining its learning with more data and adjustments. We nurture it with data, and over time it discerns patterns and predicts. This iterative process of learning and refining is the essence of training AI models. And it's this process that will take us from AI novices to seasoned pros. But how do we ascertain its learning accuracy? That's where validation steps in. Think back to your school days. Remember those surprise pop quizzes your teachers loved to spring on you? They were not just a way to keep you on your toes, but a method to gauge how well you understood and retained the lessons. Similarly, validation data serves as a pop quiz for our AI model. The training phase is akin to the classroom session, where our model is taught with the help of training data. But how do we know if our model has truly understood the patterns and can make accurate predictions? We test it. We present it with fresh, unseen data and see how it performs. This is the validation phase. Validation data is different from training data. It's a separate set that our model hasn't seen before. It's our way of checking if the model can apply what it learned from the training data to new, unfamiliar data. It's crucial to keep training and validation data separate. If we expose our model to the validation data too early, it might ace the test, but it could struggle when faced with real-world data. It's like sneaking a peek at the answers before a test. You might ace the test, but you won't truly learn the material. Just like a pop quiz gives teachers a snapshot of their students' comprehension, validation data gives us an insight into our model's learning capabilities. It helps us understand if our model is on the right track or if it needs more training. Through this pop quiz, we get a clear picture of our model's strengths and weaknesses. We can then take steps to improve its performance, refining and tweaking it until it's ready to face the world. Remember, the goal of training and validating a model is not to create a model that's perfect in the lab, but one that can adapt and perform well in the unpredictable real world. And that's why validation, this pop quiz, is so important. Validation data acts like a pop quiz, testing our model with new unseen data. Many often wonder about the ideal split between training and validation data. It's a critical question, as this balance significantly impacts the model's learning trajectory. A widely accepted guideline in the realm of AI is the 80-20 principle. Picture this: you have 100 data points. The 80-20 principle suggests using 80 of them for training and the remaining 20 for validation. This ratio is not set in stone. The distribution could vary depending on the size and nature of your data. Nevertheless, the 80-20 rule serves as a useful starting point, striking a balance between robust training and thorough validation. Imagine training your pet dog. You wouldn't want to spend all day teaching it tricks, would you? It needs time to rest, to absorb what it has learned, and to adapt it to different situations. The same principle applies to AI models. Training a model with too much data for too long can lead to a phenomenon known as overfitting. Overfitting is like a student who crams for an exam, memorizing every detail. The student might score well in the exam, but ask them a slightly different question, and they're stumped. In the same way, an overfitted model performs exceptionally well on the training data, but struggles with new, unseen data. It's so finely tuned to the training data that it loses its ability to generalize, to adapt to different scenarios. Therefore, the training process is a delicate dance. It's about finding that sweet spot where the model is well trained but not overfitted. It's about ensuring that our AI learner is versatile and adaptable, ready to take on the real world with all its unpredictability. Overtraining can lead to overfitting, where a model becomes overly attuned to the training data, compromising its adaptability to fresh data. Remember, the goal is to create a model that not only learns well, but also applies its learning effectively. In summation, training and validation are at the heart of AI refinement. This is the core of the process, the beating heart that keeps the AI model alive and learning. It's a meticulous, iterative process that requires patience and precision, much like sculpting a masterpiece from a block of marble. Think of AI refinement as a fitness journey. When we first start exercising, we don't immediately see results. It takes time, consistency, and continuous tweaking of our workout regimen to start seeing positive changes. The same principle applies to refining an AI model. We start with the raw material, a heap of data. The first step is training, where we feed this data to our AI model, allowing it to learn and grow. This is like the initial phase of our fitness journey, where we're just starting to get into the rhythm of exercising regularly. But just as regular workouts alone aren't enough to achieve optimal fitness, training data alone isn't enough to refine an AI model. We need to validate, to test our model with fresh data, to see how well it can adapt to new situations. This is akin to incorporating different forms of exercise into our routine to test our overall fitness level. Just as we adjust our exercise routines based on our performance, we tweak our AI model based on its performance on the validation data. We adjust, recalibrate, and retrain in a continuous cycle of improvement. This is the heart of AI refinement, a harmonious blend of data ingestion, iterative tweaking, rigorous testing, and continuous evolution. However, as with any fitness journey, there is the risk of overdoing it. Overtraining can lead to overfitting, where the model becomes too attuned to the training data and loses its ability to adapt to new data. It's a delicate balance to strike, but it's crucial for creating a robust and versatile AI model. Training and validation are a harmonious blend of data ingestion, iterative tweaking, rigorous testing, and continuous evolution. This is the heart of AI refinement, the engine that drives the AI forward, always learning, always improving. As we conclude, ponder an AI tool you frequently use. It could be the voice assistant in your smartphone, the recommendation feature on your music streaming app, or the navigation system in your car. These seemingly simple tools are the result of countless hours of meticulous training and validation. Think about it. Every time your music app suggests a new song you end up loving, that's an AI model successfully applying what it has learned from countless data points, including your personal preferences. Every time your voice assistant accurately interprets your commands, it's a testament to its rigorous training and validation. And when your navigation system predicts traffic and suggests alternative routes, it's the AI model at work, continuously refining its understanding of the world. So as you go about your day, remember the intricate dance of training and validation behind every AI tool that makes your life a little bit easier. And before we part, if you found value in this episode, do hit that subscribe button and share it with friends curious about AI. Your support helps our community grow. Remember, every click, like, and share fuels our passion to bring more enriching content your way. Until next time, stay curious, stay inspired, and as always, happy learning.